Hello there, this is the second part of our first lesson on factoring for our grade 10 class, grade 10 academic math. Now that we've got the basics hopefully under control, or at least feeling a little bit more comfortable about what common factoring is, we're going to look at some examples that will be relevant as we move through the course and as you move through your math career in high school. Our first example of an extension of common factoring, you'll see it right here. It is 5x bracket x minus 1 minus 3 bracket x minus 1, 5x bracket y minus 1, and minus 3 bracket y minus 1. So first thing I want to point out here is that we are dealing with two terms. There's our first term. It's big and it doesn't necessarily look like most terms, but that is a single term. And here we have our second term. So what we have here are two terms. Now they haven't been expanded out, but there's two of them. So if I were going to common factor this, I would be looking for my greatest common factor. And then in my brackets, I would have two terms remaining. So let's look a little more closely at these two terms. 5x bracket y minus 1, that's our first term, and negative 3 bracket y minus 1. What is the greatest factor that's common to both of these terms? Similar to what we were doing above. Well, the greatest common factor, interestingly enough, is this binomial that's hanging out here at the back of each of the terms. Is it okay to have a binomial that is your greatest common factor? It is. So let's put that in our greatest common factor section. So it's y minus 1. Now if I were to factor out y minus 1 out of the first term, what do we have left? Just the 5x. And if I were to factor out y minus 1 out of the second term, what do I have left? Negative 3. So this is what happens if you have a common factor, a greatest common factor in your two terms that happens to be a binomial. It's totally fine. It's a little bit weird looking, like even being able to identify what we started with as just having two terms is a bit of a stretch because, like I said, we don't usually look at terms that haven't been expanded out and simplified. But there you go. There's our first application of this. Let's look at another similar example over here. So we have 8x bracket x plus 3 minus 2 bracket x plus 3. So again, in this scenario, we have two terms. So we have two terms. I'm going to set this up. Again, we're looking for a greatest common factor. And then inside the bracket, because we had two terms at the beginning, we're now going to have two terms at the end. So what is the greatest common factor in both of these terms? Again, this x plus 3 is the greatest factor common to both. So let's factor that out. Put it right here. Now when we factor x plus 3 out of the first term, what's left is 8x. And when we factor x plus 3 out of the second term, we're left with negative 2. Now, this looks done. However, if we look at this binomial, x plus 3, is there any common factoring we can do inside of that bracket? There isn't. There are no common factors between x and 3 other than 1, and 1's kind of always going to be a common factor on things, but we're looking for more than that. The second binomial, however, we have 8x, and we have minus 2. We have a factor that we can factor out of there additionally. So I'm going to write that x plus 3 one more time. But what is the greatest factor common to both 8x and negative 2? And what you'll see is that it is actually a 2. And when we common factor a 2 out of 8x, we're left with 4x. And when we factor a 2 out of negative 2, we're left with negative 1. Now, you could leave it like this, absolutely, with that 2 hanging out in the middle. I would say the most recognizable way to do this, however, is to rewrite your monomial at the beginning, followed by your two resulting binomials. And so that is now fully factored. So I guess the takeaway from this one is that even once you've common factored out something from two terms, there may be further common factoring that you can take out of the resulting binomials or trinomials or whatever you have in there. Now, I do want to point out that these two examples that we've just done, expanding them back out will not necessarily get you what you started with because we had unexpanded terms in the original examples. So don't worry about expanding these ones out to double check them because they won't come out exactly as they looked at the beginning. Okay, let's move on to the second application. Second application is solving for the indicated variable. Now we did this all the way back in Unit 0 where this was called solving literal equations, basically isolating variables in equations without a lot of numbers. So at that time, we didn't ever look at a scenario like this where we would have h's. Sorry, so I'll just read the question first. 2a equals ah minus bh, and we're trying to isolate h. So at the end of the day, we're going to have all the way at the bottom, h equals blah, 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 something. So this we would find challenging because what you'll notice is we have h's in two different spots. They can't be further simplified. We can't combine ah minus bh and have a single h term because they're not alike. But now that we have this factoring tool in our tool belt, what we can do, so there's our 2 capital A, I'm going to factor h out of these two terms. And when I factor h out, I'll have something left in these brackets. So again, the thinking is h times what, and I'll just draw it in that one time, h times what is going to give me ah. So the answer, of course, is A. And h times what is going to give us bh. And the answer is negative b. So now we have our h's all in one location. It's easier for us now to isolate it. So we have 2 capital A equals h bracket a minus b, close bracket. So at this point, what is happening to our variable h? There's h, try to keep track of it. It's currently being multiplied by, in brackets, a minus b. So how do we undo multiply by brackets a minus b? We are going to divide both sides by a minus b. And that gives us, at the end of the day, 2 capital A over a minus b equals h. So again, this particular question we've seen before, but we were able to utilize factoring to take a variable from two locations that can't be simplified and get it into a single location that we can then use opposite operations to isolate. So that's how this one works. Let's look at the B example here. So we have r minus 3a equals 5ac for a. Okay, so same as before, we have a in two different locations, and it can't be simplified because the terms are not alike. One's an a, one's an ac, so we're stuck a little bit. However, what we can do is if we get all of the a's on the same side of the equation, then we can common factor it out again. So that's what I'm going to do here at the beginning. I'm going to get the a's all together, and how I'm going to do that is I am going to transpose negative 3a by adding 3a to both sides. So my next line then will look like r equals 5ac plus 3a. And now I have the a's on the same side. Let's keep track of them. So there's our a and our a. It's still in two locations. So the way to get it into one location is to common factor it out of this binomial. So there's an a. There's the spots for the two terms that will result. So if I common factor a out, what will I end up with in this first bracket? 5c. And if I common factor a out of the second term, there's my plus 3. So we're almost at the end here. There's that a. And as before, what's happening to a? Well, now that we factored it out, it's being multiplied by 5c plus 3. So how do we isolate a? We undo multiply by 5c plus 3 by dividing both sides by 5c plus 3. And that gives us, as a result, r over 5c plus 3 equals little a. And that is how we use factoring to isolate a variable that was originally in two different locations that couldn't be simplified, and we brought them back together. Now, the second page of this lesson is an application that, if I'm being totally honest, I don't know that we're going to necessarily need that this semester. So I'm going to just leave this. If people are feeling like they'd like to see it, I will make a video about it. But if you want to just skip number 3 and just go right on to the homework, that would be totally fine with me. So again, good luck. This is, as I said, a new and difficult concept, so give yourself some time. I guess the nice part about the videos, maybe even better than classroom lessons, is that you can re-watch it over and over to try to understand what's going on. Mr. Smith doesn't usually have a repeat button in class. I would usually just have to explain it a second time. So now you can just kind of play me over and again as many times as you need. So good luck with this. If you have any questions, obviously feel free to email me, but yeah, good luck.